Hello class, this is lesson 15.5, Angle Relationships in Circles. In this lesson, the goal is to identify and describe relationships among inscribed angles, radii, and chords. So there are three main theorems that we're going to be learning in this lesson particularly. One of them is called the intersecting chords angle measure theorem. The other one is called the tangent secant interior angle measure theorem, and then the third one is the tangent secant exterior angle measure theorem. So we're going to go through each one one at a time so that you understand the theorem. We have some examples, and then we're going to be doing the your turn problems together. So to start off with the intersecting chords angle measure theorem, the theorem actually talks about chords. Now remember that a chord is a line segment that hits a circle at 2 points. So this is a chord and this is a chord. Notice that when two chords intersect, what forms are two arcs. So we have arc CD and arc AB. And then what also forms is an angle from these two chords. So the way this theorem goes, to find the measure of this particular angle, what we do is we take the sum of the two chords and then take half of that. And here is the actual theorem. So the measure of angle 1 is equal to half of the measure of arc AB plus the measure of arc CD. So let's look at a first example using this theorem. And the work is already done on the side, but I'm just going to walk you guys through if you were doing this problem from scratch, how will we do it? So in this example, find each unknown measure using the given figure. Now the unknown measure that they want is the measurement of angle RPS, which is this angle here. The measurement of angle RPS is similar to the measurement of angle 1 in the theorem. Now, with these two chords, we have two arcs that are produced. So we have arc QT and arc RS. And remember that we need to take the sum of these two and then take half to find this angle, RPS. So here is the setup. The measure of angle RPS is equal to 1/2 times the measure of arc QT plus the measure of arc RS. Now notice, let's look at this formula and let's look at the theorem formula. Notice the similarities and differences. One being that you're not always going to have the measure of angle 1 to solve for. You're going to actually have in this problem the measure of angle RPS. But this is the angle that is formed by the two intersecting chords. So we can use this. Half is the same, and then you have the two arcs added together. So adding the two arcs, 59 plus 201, you get 206 or 260, and if you take half of 260, you get 130. And so what this occurs is the measure of angle RPS is 130 degrees. Okay, let's move on to the next page. And we're going to do one more example that's already completed for us, walk you guys through it, and then you guys are going to try some on your own. So in this example, we want to solve for arc PR. So we want to solve for the arc. Okay. We do have an equation, and the equation involves the angle that is formed and the two arcs. So we set up the equation the same way as the last problem. The measurement of angle QTS, so this measurement, is equal to half of arc QS plus arc PR. And for arc PR, I'm just going to call that X. And when they did this problem, they just called it the measurement of arc PR. So let me just do this right here side by side so you guys can see the similarities and differences. So we're going to have the angle, so 58 is equal to 1/2 of arc QS, which is 82, plus X, that is arc PR. So we have this algebraic problem and we need to solve for X. So the first thing that we do is we get rid of the half by multiplying both sides by the reciprocal. So let me use red to show you that. We're going to multiply both sides by 2/1 here and here. Okay, so 1/2 times 2/1, these reduce, so they pretty much go away. 2 times 58 is 116. So we end up with 116 is equal to 82 plus X. Next, we want to solve for X, so we need to subtract 82 to both sides. Subtract 82 here, and then subtract 82 right here. These are going to cancel out, and then 116 minus 82 is 34. So X is equal to 34. And we called X arc PR. So that answers our question. The measurement of arc PR is 34. Okay, for the next two problems, if you want to pause the video here and then try these on your own, you guys can. And then when you guys are ready to look at the solution, you guys could press play. So I would strongly suggest that the first step is not to jump into the... Don't start by substituting, start by creating your equation. Let's look at what they're asking for number one. They're asking for the measurement of angle MPK. So let's find out where that is. The measurement of angle MPK is this angle here. So the formula would be the measurement of angle MPK is equal to 1/2. And now it doesn't really matter which arc we write first or second. So I'm just going to write arc KM. So the measurement of arc KM plus the measurement of arc NL. So now that we have our equation, we could easily plug in the numbers. So we have 1/2 times 61 plus 111. Doing PEMDAS, we add inside the parentheses. 61 plus 111 is 172. So we have half of 172. And then if we take half of 172, that ends up with 86 degrees. So the measurement of angle MPK is equal to 86 degrees. Next, for problem number 2, we want to find the arc. So this is just like example number 2. So the arc that we're trying to find is arc PE. So this arc right here. And I'm going to use a variable just as a placeholder. I'm going to call that X. So let's set up our equation. So I'm going to write the measurement of angle CBD. The measurement of angle CBD is equal to half the measurement of arc PE plus the measurement of arc CD. Then substituting the values that we know, the measurement of angle CBD is 127. And then we have half. I'm calling arc PE X, So that's x plus 134. Close the parenthesis. And again, to get rid of the fraction, we need to multiply both sides by the reciprocal. So the reciprocal would be 2 over 1. So that cancels the half. 127 times 2 is 254. Is equal to x plus 134. So I could drop the parentheses now that I remove the half in front of the parentheses. And then I could just subtract 134 to both sides. And 254 minus 134 is 120. So x is equal to 120, and that answers our question. The measurement of arc PE is equal to 120 degrees. Okay, so that was the intersecting chords angle measurement theorem. So that's the first theorem that we're going to be talking about in this lesson. Let's talk about the second theorem. So the second theorem is called the tangent secant interior angle measure theorem. So what we expect from the name of the theorem is a tangent segment and a secant segment. So if we look at this diagram here, this is the secant segment and this is the tangent segment. And what we're trying to find out is the interior angle that is formed from a secant and tangent segment. So we're trying to find out what angle ABC is, which is this angle here. Now this formula is pretty straightforward in that we just need to find out what arc AB is to find angle ABC. So we take half of arc AB. So let's look at the first example here. For number 1, we want to find the measurement of angle BCD. So BCD is this angle here. Okay, so then we need arc BC, and we know what arc BC is. Arc BC is 142. So to plug in the numbers, we have the measurement of angle BCD is equal to 1/2 142. And half of 142 is 71. Okay, next, let's find out what the measurement of arc ABC is. Now, this one, we kind of have to look at the entire arc ABC, this arc here. The measurement of arc ABC is unknown. What is known is the angle that is formed from that arc is 90 degrees. So angle ACD is a right angle that's 90 degrees. So we could use our equation the same way, set it up. The measurement of angle ACD is equal to half the measurement of arc ABC. So we have 90 is equal to 1/2 the measurement of arc ABC. And then we have to get rid of the half by multiplying both sides by the reciprocal. So what they did here was they multiplied both sides by 2 over 1. And 2 times 90 is 180. So this entire arc is 180 degrees. Now, we could actually find different things. Knowing that the entire arc is 180, we could find out what arc AB is, but we don't need to. So we found out what the measurement of angle BCD was for problem number 1, and then we found out what arc ABC was, which was 180. Okay.
Then let's look at these two problems together. And if you want to pause the video to try this on your own, please feel free to do so. For number one, they want us to find out the measurement of arc PN. Okay, so the measurement of arc PN is here. I'm just going to highlight that red. What forms that arc? We're trying to find out what angle forms that arc. And that is this, I don't know if you guys can see it in purple. So angle P forms arc PN. So let me write that formula for you guys. Angle P is equal to 1/2 the measurement of arc PN. And I know angle P is 61, so I have 61 is equal to 1/2 times the measurement of angle PN. And then I know to get rid of the half, I need to multiply both sides by the reciprocal, which is 2/1, or just 2. And 61 times 2 is 122. So the measurement of arc PN is equal to 122 degrees. Okay, next we could find problem number 2, the measurement of angle MNP. So now we want to find out, I want to use green, we want to find out this angle, MNP. So to find angle MNP, I need the arc that is formed from that angle. So arc PQM or PQN is 238 degrees, and that's all I need. So let's set up the problem. We're going to have the measurement of angle MNP is equal to 1/2 the measurement of arc PQN. And try not to get the, I know saying all these letters might be confusing. Just try to trace what you're trying to find. PQN is this entire arc. PNM is this angle. So just be careful when doing this because there are a lot of letters. Just take your time in highlighting what each one is. So arc PQN is 238. So I'm going to have 1/2 of 238. 1/2 times 238. That becomes 119, I think. So the measurement of angle MNP is 119 degrees. Okay, and then let's go on to the last theorem in this lesson, which is the tangent secant exterior angle measure theorem. So one key word I want to point out is this word exterior. The angle is exterior, meaning that the angle is outside of the circle. Versus in the last problem, or the last theorem, the angle was in the interior. It was inside the circle. So just keep that in mind when you're given a problem. Just make sure that you understand
if it's a interior angle or exterior angle. Okay, so there are going to be three types of tangent, secant, exterior angle measurement theorems. Okay. So let's kind of go through each one. But the formula is the same for all of them. So for the first one, we have a secant line and a tangent. So what I'm going to do is I'm just going to write tangent dash secant. Okay, because that's what we have. We have a tangent line and a secant line. For this example, we actually have two tangent lines. So I'm going to write tangent, tangent. And then for the last one, I actually have two secant lines. So this is a secant and a secant. But again, notice that the equation for all of these is the same. What we're doing to find the exterior angle is taking half of the major arc, so the large arc, minus the small arc. Now you always want to say the large arc minus the small arc to get a positive answer. So that's how we're going to be doing each equation. So the major arc EHG and the minor arc EG. The major arc JN and then the minor arc KM. So usually the arc that is farthest away from the angle is going to be the major. So I'm just going to write, if I can here, this is the major arc. And then I'll put an arrow here. This is the minor arc. So major arc minus minor arc. Okay, now let's look at an example that's already done for us, but we're just going to walk through the steps. So we have, when we look at a problem, we have to kind of identify which one it is. Is it a tangent secant, a tangent tangent, or a secant secant? Now this one is a secant secant, and the way we're going to write our equation is the measure of angle L is equal to half of arc JN minus arc KM. So looking at the equation, we have 25 is equal to 1/2 times 83 minus x. Now I think we should be familiar right by now of how to get rid of the fraction. What do? We multiply by the reciprocal 2/1 to both sides. So we end up with 50 is equal to 83 minus x. Subtract 83 to both sides. And then we have to divide both sides by -1. So x equals 33. Okay, now let's look at problem number 2. And there's a twist with problem number 2. So let's kind of talk about that twist. To start off, this is a tangent-tangent exterior angle. And we know that this is going to be the major arc. The major arc is 238. And the minor arc we don't know. But we need to know this to find x. Now, the trick is that from this point all the way across to this point is 238 degrees. Knowing that a circle is 360 degrees, we could find this other arc by subtracting 360 from 238. And now that's what they did here when they did the setup. That's why you see 360 minus 238. That's because this piece is 122 degrees. So this only works for tangent-tangent examples. So tangent, tangent. Okay, now that we have the major arc and the minor arc, we subtract these and take half. So 238 minus 122 is 116, and half of that is 58. Next, this is just some problems to try on your own. If you want to pause the video here and then take a shot at these problems and then look or press play after to look at the answers, you guys can. So the setup for number 1 is x, so the angle, is equal to 1/2 of the major arc, 161, minus the minor arc. 161 minus 67, I want to say is 94. And if we take half of 94, I get 47. X equals 47 degrees. Okay, number 2. The superior oblique and inferior oblique are two muscles that help control eye movement. They intersect behind the eye to create an angle as shown. If the measurement of angle AEB is 225, what is the measurement of angle ACB? So we have AEB is 225 degrees. Now remember that with tangent-tangent segments, we could find this minor arc by subtracting 360 by 250 or 225. 360 minus 225, I'll do this on the side. So 360 minus 225 is 135. And that's what the minor arc is here, 135 degrees. So when setting up our problem, we're going to have the measurement of angle ACB is equal to 1/2 the major arc, 225, minus the minor arc, 135. 225 minus 135 is 90. So we have half of 90, and that is equal to 45. So the measurement of angle ACB is equal to 45 degrees. Okay, now that we finished that, the next part is just about understanding angle relationships in circles. And one way we do that is by looking at where the vertex of the angle is located. So the vertex is the pointy part of an angle. So here the vertex is located on the circle. Here the vertex is located inside the circle. And here the vertex is located outside the circle. So we could kind of see the formulas that we're going to use. So if the vertex is on the circle, we just take half of the arc to find the angle. If the vertex is inside the circle, we take the sum of the two arcs and then take half. And if the vertex is on the exterior, we subtract the arcs. So if it's on the outside, we subtract. If it's on the inside, we add the two arcs. And notice that all of these have a half. We take a half for each one. Okay, so now let's look at this first example. Find the unknown arc measures using the circle below. Now what they want us to find is arc FD, so let's highlight where that is located. Arc FD is located right here. So what we need to find out is what angle, or where is the vertex of the angle located that forms this arc. And if you look at this angle here, angle BEF, so you see this angle here, this is an outside, the vertex is on the outside, and we know that formula is the measurement of angle E is equal to 1/2 the major arc minus the minor arc. So 150 minus arc FD. And that's what they did here. So 50 is angle E is equal to 1/2 times 150, that's the major arc, minus the minor arc FD. Doing the math, we multiply both sides by the reciprocal, and we get 100 equals 150 equals the measurement of angle measurement of arc FD. Subtract 150 to both sides, and we get -50. Divide both sides by -1, and we get 50. Notice that when we were doing this problem, we didn't even look at this line. So just be careful when you're doing a problem that has more than one line to focus on the area. Try to find out where the vertex is located. Okay, next, per problem number 2, we have a new drawing, and we want to find out where the measurement of arc CD is. So let me highlight that here. Okay, so to find this arc, what we kind of have to do is we kind of have to find the measurement of different arcs in the circle. So actually this figure is the same as for figure 1. Because we found arc FD was 50, I'm just going to write this is 50 degrees. Let's look at how I'm going to be tracing the arc. So if I start here, from D to F, that's 50. From F to B, that's 150. From B to C, that's 64. And the question is, what is from C to D? Now, the trick to doing this problem is knowing that all arcs add up to 360 degrees. So if I'm trying to find out what arc CD is, I could set up an equation where I have 360 minus the sum of these arcs. 360 minus 264 is 96. So this would be the easiest way to find this arc, knowing that this entire piece is out of 360. Okay, now let's look at one problem. Find the unknown arc measure. So what we want to find out is what is the measurement of arc KLN. So again, let's highlight where that is located from here, from K to L to N. So when looking at this problem, I'm trying to find out how or which angle could I use to find the arc.
And I notice that angle PMN gives us arc PN, angle JNM gives us arc JK, but we already know that. So the way I'm going to be doing this is first I'm going to find out what arc PN is. Once I know what this arc is, I can find this arc by subtracting from 360. Or maybe we could do this a different way. No, let's do it that way. Okay. So, to start off, we're going to look at this angle here, and this is an outer angle. Or actually, we can't do that because we don't know these arcs. Okay, so I got kind of stuck on this problem, and I'm going to kind of do this a different way. I still want to find out what RKLN is, but what I'm going to be doing is I'm going to be looking at these chords, so where the vertex is inside the circle. So what the formula I'm going to be using is I'm going to be taking the sum of these two arcs and cutting them in half. So let me write the formula for you guys. The measurement of angle PQN is equal to half of the measurement of arc JK plus the measurement of arc PN. And this is what we want to solve for. So I'm going to replace PN with X just to make it easier on us. So I'm going to have 79 is equal to 1/2 48 plus X, close the parenthesis, multiply both sides by the reciprocal, which is 2/1. And 79 times 2 is 158. So I'm left with 158 is equal to 48 plus X. I could subtract 48 to both sides, and I'm left with X is equal to 110 degrees. And that is what I need. It's like a puzzle. We need this piece to find the other piece. Okay, this was the first step. The second step is now finding our KLN. So let me write that below here. The measurement of our KLN is equal to 360 degrees minus the sum of all these arcs. So I'm going to start just by writing the variables. So the sum of arc KJ plus arc JP plus arc PN. Using this formula will give us arc KLN. So we have 360 minus 48 plus 86 plus, sorry, this is supposed to be 110 plus 110. So then this is just a calculator problem, but I don't have a calculator, so I'm going to try to do this without a calculator. 48 plus 86 is 134 plus 110, that gives me 244. So this pretty much is 360 minus 244
and that is 116 degrees. So measurement of our KLN So when I started this problem, I was stuck because I was trying to use a method that didn't work because I wasn't given the certain angle measurements or arc measurements that I needed to solve the problem. So I went a different route, and we were able to solve for x, and then we were able to find our KLN. Okay, so that completes lesson 15.5. This is lesson 15.5 homework. Now, looking at this homework, I just want to kind of walk you guys through what we're doing here. We're going to have problems where the vertex is on the circle. So this is on the circle, on the circle. We're going to have problems where the vertex is inside the circle, and then you're going to have problems where the vertex is outside and on the outside. So I think what I'm going to do is I'm going to set them up for you guys just so you know how to go about the problems, and I'm going to focus on problem 2, 4, and 6. So I'm not going to solve them, but I am going to set them up for you guys. So starting with problem number 2. We want to find minor arc KJ. So we want to find this arc. So this is the formula that we're going to use. The measurement of angle JKL is equal to 1/2 the measurement of arc JK. So we plug in the values. 60 equals 1/2 times the arc, and we could solve. Okay, next for problem number 4, we want to find arc PE. So again, let me highlight this because it helps me to find out what I'm trying to find. So this is a problem where the vertex is inside the circle, and I know that I have to take the sum of the two arcs to find the angle. So let me write the formula for you guys. The measurement of angle CBD is equal to 1/2 the measurement of arc CD plus the measurement of arc PE. And you're going to probably want to use X for PE. So we know this is 127. We know this is 134. We know this is X. And you could solve for X. Okay, the last example that we'll do together is number 6. And the vertex on this one is outside the circle. So this should be a good indication that this will be a subtraction problem. So the angle, so the measurement of angle STV is equal to 1/2 of the large arc, so the measurement of arc SV minus arc SU. So the major arc minus the minor arc. Now we're going to call this SUX. SV is 220, and we know angle STV is 70 degrees. So hopefully that helps you guys get a head start on the homework and understand how to do problems 1, 3, and 5. And then you still have the checkpoint after the homework. All right, take care, guys.